Now we're going to get kind of right into this. We're just going to give our panel up here, they're going to give a little overview on where they're from and kind of whatever, and what they do and their liquid agents that they're using. And we have Jeff LeCorchick, Ryan Lynch, and Steve McCarty. And Jeff came from the furthest, so maybe, does he want to start? Yeah. All right, Jeff is going to start.
Good.
Okay, well, I just got voluntold to begin, so I'd love to. My name's Jeff LeCorchick. I'm with Ingevity. Ingevity sells warm mix additives and liquid anti-strips to the asphalt industry. My background is all paving. Ever since graduating from school, I've been in the hot mix industry, mostly on the production side. I started at a ground level, working at a plant, worked my way into running heavy equipment, then the lab, production, running a plant, and then managing plants. So everything I know is real-world applications with asphalt, and long story short, I'm an industry nerd. I love everything about it. I feel like it's an ever-changing thing. Our goalposts are always moving, and unlike maybe concrete, we always have different performance tests coming out and different things to think about. So it's something that I love, and I'm a true industry nerd. So, Steve.
Awesome. So Steve McCarty, I'm with Aaron Swan Associates, stationed out of Pierce, South Dakota. I'm not sure quite why I'm here, but I'm here. So I had a lot of mix designs. I'm doing 80 plus mix designs a year through our little lab. So I guess we work with a lot of additives, warm mix additives, anti-strip additives. So just kind of here for that aspect. Just kind of the layman guy, the mix design guy, and what we do with some of these additives when they're put out there for us to look at. So that's pretty much me.
Yeah, and Ryan Lynch, very similar. I grew up in the industry. I guess my first introduction with additives was when I was selling asphalt for Flint Hills Resources and working with Ingevity. Then it was Midwest Vaco with Evotherm. This was probably 2008 timeframe. Looking at it as a warm mix additive and then as a season extender. And then as my career kind of went on, we started developing additives internally at FHR and then shot that off to a different company within Koch Industries. And then through a couple different shifts in companies, worked on probably 3 different types of technologies throughout 3 different companies. I'm now at Ergon, pretty much doing the same thing. Whether that be, and kind of today, we're going to need a lot of input from all of you because we'll all just kind of talk about what we've seen. But, you know, what we kind of want to cover is maybe not so much innovations, but where the technologies are now and where they could go utilizing them. I think a lot of these technologies you're going to see have been the same technologies for a better part of a decade and a half. It's just how we're utilizing them, how we're learning to kind of put them into our toolbox and improve the pavements with varying degrees of asphalt quality and varying degrees of aggregate quality and all of the above. So with that, I guess I'll turn it over to our moderator.
Well, as I went around, you know, as I go around nationally and I get bombarded by a lot of additive groups, you know, and I got to kind of watch myself because as you speak about some of this stuff, as I talk about it, well, everybody's got a passion for their product, and I understand that. Do I understand? Am I a chemist? Absolutely not. But I do understand one thing, that eventually somebody's going to come up with something. And whether it's, you know, 5 years, maybe it's 10 years, maybe it's next year. You know, with all the, you know, the problems that we have at some point, you know, if you look at where the asphalt is actually came, which I think is the only additive that there should be, just so you guys know that. Because I'm actually, I don't know if you know me, I'm Mike with the Dakota Asphalt Paving Association, so. But anyway, our goal is the longevity of the asphalt. We want to make better roads. That's what we want to do, longer lasting. You know, and some of that's got put by the wayside over the years. I remember 20 years ago, it's, well, if it only lasted 10 years, I guess, well, so be it. We'll be able to do it again next year, you know, so it's just the way that works. But that's what the hope is here, and that's why I want you to ask questions, you know, kind of open it up and raise your hand, and I'll run a mic out to you. And we just want to ask the, the group or what they think is coming next. These people see this where we don't see this every day. They got the things, okay, the Evotherm, and Ryan's got his. I don't really know what they're thinking. And I mean, I see so much of it. I see even some rubber additives coming that they're trying to push. And I'm, to me, I'm like, well, you're not impressing me any. I'm the one that you don't have to impress. You got to impress the DOTs. And how do we do that? And that's where innovation sometimes is just slow to come about. It takes longer than probably what it should, because obviously the owners, they don't want to try something really, really new unless it's 100% that they know is going to work. And then it takes so long to get that innovation into it, and they say, geez, we should have did that 10 years ago. Well, that's what we're trying to figure out, is how we can, maybe try some of this, small test projects or something, to see how it works. Another thing that's not a very good is when we do, like even this North Dakota and this balanced mix design. If you look around the room in 10 years, there's a bunch of us that are probably not going to be sitting here anymore. What I've seen in the last 30 years, there's stuff sitting in a file cabinet in my old office that we tried. We tried some of this stuff 15, 20 years ago, but you know what? Got lost to the wayside. Here's the thing, they want to go high wrap. Well, back in the 90s, we were running 50% wrap over in Minnesota on a lot of projects. And then that to the wayside. I was at a conference, I'll never ever forget it. The guy goes to me, well, I think we should go to 50% recycle. And I kind of looked at him and I said, well, we did that, but it was a whole different thing. There again, we just had a minimum AC and it was put on the base course. It's the asphalt cement, because I got that one time at a conference. I was abbreviating too much. But anyway, so if you do that and you come in, at 50%, well, some of it failed. Well, then that went by the wayside. So now here we come back 20 years from now. Okay, well, now we're going back to 50%. So what do we do different? It's kind of like even that cold in place that we did a lot of that in the early 90s too. And we put, the additives in there and some of it worked, but some of it failed miserably. And that's what the questions that, I want you to all ask these, our panel here. We got a lot of knowledge here. So maybe we can come up with something.
And if you don't, I'm going to take you through a very boring history of asphalts that I've got teed up here. So please, any questions to start?
I'll jump in there, Ryan, since hands aren't flying up right now. And I think the whole point of this discussion is to really bounce some things off you guys. Mike just said this is about additives, but he thinks the only additive that should be in asphalt is the oil. And I love that, because that is just old school knowledge right there. I would push back on a lot of that, of what he said, but that's just my opinion. And I think that this is why we should have these conversations. And please push back, tell your experiences, say what's worked and what hasn't. I feel like we have to unpack a lot of different things up here. When we talk about additives, we're going to talk about liquid anti-strips. We're going to talk about warm mix chemicals. Those can actually be the same. We should talk about rejuvenators. I think Ryan's going to talk about some additives in emulsion and CIR, cold in place recycling. So when we talk about additives, there's a lot to unpack and kind of digest. But Mike's right. For wrap, we used 50% wrap decades ago. Some projects failed and some didn't. But I think what for instance, the North Dakota DOT is trying to understand right now is why those projects failed. And to say that, a high wrap project failed without talking about the binder grade right now at the end or the ideal CT numbers is something of the past. So when we talk about why projects are failing, I think we're getting into the data now and the reasons as to why. And I feel like this is why we're up here talking about additives. Like we mentioned before, the industry is evolving, and these are products that help. It's hard to tell someone who has 30, 40 years of experience that you need this, 0.5% of an additive or, things aren't going to work. Because at the end of the day, the most important thing is rocks and oil. And these additives are just, an extra benefit to the performance of these. But understanding the performance tests, understanding what's driving these additives really should be the core of this conversation. Sorry to disagree with you already, Mike.
Well, and let me maybe agree with Mike a little bit. The only additive that matters is the asphalt, is what I'll say. And I know that sounds weird coming from someone who's saying that. In the end, that's what matters. All these other additives, all they're trying to do is make that asphalt molecule work like it should, age like it should, resist wear and tear like it should. And so, I mean, let's look at binder. We're talking about asphalt binder now. Delta TC is really, it's the metric of the day. There is others out there, but let's just keep it to that. It's very simple for a commercial guy like me to understand. Lower the number, the worse it is. Higher the number, the better it is. I mean, anybody can figure that out, even a history major. So what we're seeing, though, is that with these additives, sometimes when you put this through an aging protocol, which is in a pressure aging vessel, I'm sure most of you guys know what that is, these additives will help that asphalt resist the aging a little bit better. It's not that they're rejuvenating it. You'll see some of those there. It should always be in quotation. They're just becoming a different type of asphalt molecule that just resists age a little bit better. And so you can have additives that hurt delta TC. And it's not that the additives are aging, it's just they're not aging. Like reob, for example, is it's a 4-letter word, literally and figuratively, because it's all just sitting there inertly and not doing anything. And so all these aging, whatever you want to call them, free radicals, whatever, is going just on that asphalt molecule. And the reob is just sitting there and not aging at all. So that's why you see those degrade. Where you look at a bio oil or a TOFA-based chemistry, that is actually commingling with those asphaltenes. And I mean, maybe we should just go to that slide, right? And there's your asphalt molecule, right? So it's not rejuvenating, it's not reacting, it's solvating. It's breaking up that asphaltene structure that wants to come together, that has a very polar structure, right, with other polar materials that tend to keep that flocculation from happening. And then when it goes through an aging protocol, it doesn't age as quickly. It has that viscoelasticity, but it's all mechanical. It's not really any kind of crazy chemical science. I mean, the chemistry comes before that and all these different additives, but that's generally what you're doing with asphalt. And that's why these additives work. That's also why it helps with compaction, because the viscosity drops. It's pretty simple. And so, I guess getting into that is that the oil does matter. And it really is the only thing that matters. It's what binds our rock together. It's what keeps the pavement flexible. It separates us from the beasts in concrete. And it does matter. But these additives just allow you to utilize your oil in a more efficient way.
I think that's a great
Steve,
point,
can
Ryan.
you hit a little bit on the different, with the problems that you see, like with high ACs and the wraps and the mixes, when you start to look at that, what that's doing with percent like new oil and stuff like that?
Wow, I have a slide for that. It's like,
it's good.
we had no script, and this is working out great. Yeah, so when you're using high RAM, which is the new term, right, it's recycled asphalt pavement and recycled asphalt shingles. It's all recycled asphalt material. And, shingles are pretty tough to use. Not many places in the country use them well. You could argue no place uses them well, but that's a whole nother ball of wax. But the problem with that is that what you're doing is you're doing the opposite of what these additives do. You're not adding viscoelasticity, you're adding brittleness. And you're just making it so that there's more asphaltenes that are aged, and it just makes the binder just act worse. If you took a delta TC of some of this wrap, I mean, you're talking -12 type numbers, when they say -5 is the absolute minimum usable, delta TC rating. So in order to address that, in the old days, you just soften your asphalt. Well, you can only soften asphalt so much. I think Husky or Cenovus makes -37, which is your low end. And that's the lowest you can go with neat asphalt. If you're using stuff with 50, 60%, you're going to want to be grade dumping twice to -40. So you're going to need to use something. That's where they started using reob. I already talked to you why reob didn't work, right? So then they started looking into the bios and looking into these products that tended to have less, saturates in it. Have more resinous materials. That's an oversimplification. If there's any chemists in the room, I'm sure they're cringing in this whole oversimplification of what the asphalt molecule is, but that's generally what's going on. And that allows you to basically maximize that wrap usage in the durability standpoint. It also matters for your equipment. I mean, you can't really run wrap in a parallel flow. That's pretty tough to do. You got to use a counterflow. And even in that, you're going to you're going to have issues in processing that wrap. You're going to have more moisture. You're going to have inconsistent moisture. These additives can all help that as well. And maybe you want to talk to that on the Evotherm side.
No, I think that's great, Ryan. Steve, did you want to talk to anything about design or incorporating it? I know Mike just asked you that.
Yeah. No, we can talk mix designs all day long. I can do that. So, and I'm, and this is as much from you guys as you want to get out of us. So on the mix design side, we're always looking at these products and I'll call these, snake oil salesmen here. You know what I mean? There's always something new. It gets thrown at me all the time. We try something, okay, it doesn't really work at mix design, and we'll throw it to the wayside and wait till someone comes up with a better idea or whatever. But we've worked with a lot of these now, these warm mix additives. Start with Evotherm, a little history in North Dakota. We use it as a compaction aid, extender of our season and everything. To incorporate these, for that, mix design-wise, not doing a whole lot. We're just putting it in the oil, mix it out there, and it does help us. Lowering the temperature of the plant as we're using it as a warm mix additive. We're not doing a lot of that here in the Dakotas. And then our antistrip agents that we're getting, we found that Evotherm, now they make different variations of all these additives to help us with actual stripping. So when we're talking about these rejuvenators and things for these high wrap contents, it gets difficult. You got to mix this up, as we were just talking about, shingles. We tried it in South Dakota, and it didn't work well. After the fact, very, very stiff and brittle. Would an additive helped along with that? Maybe, maybe not. That's what we're trying to figure out in the industry, and with all these new products coming out and developments. So using these in high wrap situations is I think we're going to see more and more of it, I think, from these guys, and ensuring that we have a mix design. So a lot of that goes to the makeup, the structure of it as well. The asphalt is a small portion when you're talking 6% and 94% aggregate. Now you take that 94% aggregate and 50% of that's wrap, some of that's oil. So to get these additives to work with our high wrap mixes is something we're trying to work with a little bit here. I haven't done a lot of it yet, but stuff I have worked with and tried to use, it does help. As far as the field and what we get for final product and down the road, I don't have that knowledge yet. I've got a couple projects out there I'm paying attention to,
Well, here's one of the challenges that if you were at the DAPA conference, I gave a presentation on high wrap. Well, the wrap that we're dealing with, the asphalt content in this wrap is somewhere. It can be, I've seen as low as 2%, and I've seen as high as 10. Okay, when you talk about high wrap, that's why high wrap don't mean anything to me. I mean, all of a sudden you start seeing 10% asphalt in the recycled asphalt pavement. Well, 30, if you put 30, if you put 2, and that's what this whole industry is basically with all these rejuvenators or whatever you want to call them. That's what they're trying to do. We're trying to get that AC to soften up and give stability or whatever, and that's where this balanced mix design, where I think is kind of coming into play. That's why everybody's pushing this way, and it's tough. Like when I know, because I used to do mix designs, and it's like you mix it up there, and all of a sudden you got 7, 8, 10 on the 200, and you got 9% asphalt cement. Well, then your percent new oil gets down to under like a low 50s. It can even at 20, 30. Well, you start getting up to 50%. Well, you got probably about 30%. Is that good for our industry? I don't think so. But hey, if something comes along that can fix that up to make it all go, we can pass these tests. Maybe that's the way to go.
Yeah, Mike, I think you just hit something on the head, and it's how we handle our wrap piles and we process our wrap piles as we start increasing wrap is really going to hit it on the head. You mentioned having AC ranging from 2 to 10%. That's a real problem, especially when you get into adding 30, 40. Nebraska is up to 50% wrap right now. And when you get into those light ends, those chip seals, you really do get different AC content. So I think first and foremost is trying to maintain consistent wrap piles is key to using high wrap. Anybody that's used high wrap knows that you can chase yourself. and that's frustrating. You know, just to go back, I feel like Ryan did a great job explaining that, but you know, the key is we're talking about using wrap and using these rejuvenators, and you know, we talk about the PG grading system of 6422. That first number of 64, that's your high-end hot temperature number that's going to be more indicative of rutting. That second number, your minus 22, is your cracking number. When you start adding wrap to a 64 minus 22, you are not going to get a minus 22. You might get a minus, Ryan, this is going to be your wheelhouse, a minus 16, a minus 12.
I mean, yeah, I mean, it depends. You know, where are you at in the globe, right? Generally, you're further north, you use softer binders to start with, so you're going to have a little bit more forgiveness there, if you will. If you're in the south, where sometimes they're paving in Arizona, I think, Greg, what do they pave in Arizona? Minus 16, roughly, usually? So there you go. You know, that's not going to be very good wrap for you to utilize. You're going to be very, very stiff. You're probably maybe even in the plus side on your BBRs, potentially.
And the key right now, as we're using more wrap, is we're worried about the cracking. And that's why we're worried about the binder characteristics. And when Ryan talks about the RTFO and the PAV, these are performance tests that are going to that are trying to judge how a binder is going to work out in the field. So these are things that we're trying to balance right now. But wrap's not going anywhere. So now we need to learn how to incorporate higher amounts of wrap while still maintaining a great life cycle for that pavement. And this is through fractionating wrap, this is through rejuvenators, these are through modifications.
Maybe good segue for, here's a true innovation that's going on looking in the future. It's a company I worked with called Nicotech. They have a plant in Columbus, Ohio. They have a deal with CRH up there. So this is a brand new way of producing asphalt, and this is 100% wrap, and there's no liquid binder used in this necessarily. In their current pilot plant, there's no liquid binder. You could add it if you want, but we talk about additives when we're talking about these liquid additives. Additives also come in other forms too. So they do use a rejuvenating type product. That's what they call it. They use a softening agent right now. They're also looking at some what you would call more anti-aging type products as well. But the other product that they use is this pelletized asphalt. This is ground tire rubber, which Mike talked about, and liquid asphalt that's been put into a pellet. So they mix that in these indirect fire type jet engine type cookers with wrap that has been properly fractionated. As we're talking about, best practices matter. You know, they can get their add oil. I've seen some of their gradation specs and then their oil contents. You're talking with 100% wrap, they're varying by like 1.3%. That's really good between batch to batch. To be able to do that with wrap is extremely hard to do. So it all starts with just the old way of doing things, fractionating wrap, and it's funny we're talking about old ways with wrap, but that's generally what you got to do. You got to handle it right. You've got to take, you know, their stockpiles and keep them. They're actually erecting Quonset huts so they can keep their stockpiles dry as well. And then they're using the additives that are there, that are both sustainable, both on the solid side and the liquid side. And they're getting as much of that binder off of that rock as they can. And, you know, sustainability may not be as important with the current administration, but my esteemed colleague from NCAT has the great way of looking at it. It's fuel savings, right? I mean, inflation's here. Things cost more to run. If you can sit there and cut your fuel savings by 50%, that's real money too. You know, the old saying that green is always green, well, that's always true, regardless of the political climates. If you can save money by also being a little bit more efficient, then that's a win-win for everybody. But there's kind of a real-world example of how you can do 100% wrap with all these existing technologies, and one we haven't thought about. And they're getting, you know, CT indexes of 60 easily on a few of their mixes. I think they're at 70 to 80. I mean, that's pretty good. I don't want to put Tyler on the spot, but I think a couple years ago when you did an average look at the mixes here in North Dakota, what were we at? High 40s on average CT? 50? Okay. So 100% wrap, and we're hitting those types of performance.
One of the things I want to say about fractionating wrap, this is a challenge for our industry, is what happens when you, in the portable market plant. You move out there, you got her crushed, you move the plant, and you get her set up, and then what? Then you start to mill up because you're going to backhaul the wrap So, and that's a big issue. So, you know, when you fractionate, how are you going to do that? That's been everybody all over. You know, the stationary plants out east and stuff, they have started to do that, and they've got mountains of wrap. But, I mean, that's everything is, it seems in this portable market, no matter what we do, there's always that challenge because we're just moving so fast, and we're here. Even the balanced mix design part when it comes in, well, you know what, 30 days, the crushers were, at least when I was doing it, was about 2 weeks behind us. So to do all these tests that they want and everything, that's the issue.
And that brings up a good point. I mean, where balanced mix design should be striving for, and I'm going to be on my soapbox a little here, is to eliminate some of these volumetric specs. You can use them, you know, at Steve's level to kind of diagnose the problem and what you have. But generally speaking, you should be able to handle that variability utilizing these additives. And as long as you're tracking it towards a performance spec, Hamburg, SIP, Ideal CT, or DCT, whatever you choose to do, you should be very confident. We saw on the Highway 14, I mean, we didn't see any surprises in that data, I don't think. Did you? I think we saw what we thought we'd see. And that
how
should
that
give you
stuff
confidence.
came out was indicative of what we were hoping to see or what we were expecting to see on those. So,
And additives were in play. Now, there may not have been these additives we're talking about, but SBS is an additive. Polymer modification is an additive. And you utilize that, you can get certain gains that you can rely on and you can predict.
so we got a vast group here. We got engineers, we got county officials, city officials, DOT, contractors as well. And I'm going to just ask the question to my counterparts as well. Probably what you guys are thinking is, all right, we got all these additives. Now, how do we quantify how much we need and what do we get out of that? How do we test in North Dakota? I hire Steve up here to do a mix design for me, and I got Jeff or Ryan or somebody comes up with an additive and says, hey, use this. Okay, what's it for? Stripping. Okay, all I can do is a TSR. So how do we implement some of this stuff is probably a question I'm guessing maybe some of you have. And I'll ask Jeff and eliminate TSR. I'm fine with that. That's a pain. You got the Hamburg. It's aggressive test. And then there's lots of things that play into every test method that we have out there. But getting a quality test that we can do in the forefront for you guys on these additives, I'm just going to throw it out there. As a layman guy, I got this much time to get a mix design out. As Mike brought up, you know, the crushing is getting going, and by the time they get me materials, they might be done. And so we're limited on what we have for types of aggregates, you know, natural materials, crushed rocks. So, you know, if you want to maybe venture some ideas there, guys, you know.
Real quick, it just goes to what I just said. I mean, you can get rid of some of these tests that, shall we say, are a bit unreliable and maybe not based in the chemistry of what's going on, like TSR, and look at something like Hamburg and SIP. I mean, you're already running a Hamburg, ideally, under these situations in a true balanced mix design environment. Why add another test to it? That's an example where you can eliminate some specs. So you don't have spec creep, and you don't have more for people to manage.
I love that answer. Yeah, you know, I think the other key driver is just understanding, you know, what our outcome is. You know, when we use these chemicals, are we trying to improve the adhesion from the binder to the rock? Are we looking for better compaction? Are we looking for better binder properties by cooking the asphalt at a lower temperature? Are we looking to replace a 200 and not put lime in because we're already using high wrap and maybe not fractionating? You know, I think this speaks to the ever-changing goalposts in the paving industry on a daily basis and weekly basis, and it's never the same. And I think this is the same in state to state and market to market. Because there's just different driving factors. You know, at the end of the day, all these additives that we're trying to use, it gets back to what Ryan said in the beginning. We're just trying to make a better pavement. We're trying to make it last longer. And I think it's your job out there, the DOTs and the labs, to understand what performance tests work and to understand what additives really work because, you know, they're not all the same.
You know, I'd chime in, you guys. They gave you guys like the toughest topic to talk about here because what's an additive? I mean, modifiers are additives. Wrap is an additive.
Mark, come on up here. We could probably use you up on the stage here, you know?
Come on up, my friend.
So, how many were born after 1979? I did my first mix design in 1979, doing Marshall mix designs, and that was with 50% wrap, okay? So that's been a long time ago. But we're in a major transition in our industry, really, in that when I used to do mix designs back in the early 80s, I could take a virgin aggregate, I could take a pretty good binder, I could do a mix design. I could sleep pretty good at night that that was going to perform the way I expected it would perform. So much has changed. Number one was traffic loading. The Federal Highway Administration in 1982 changed the legal loads from 72,000 to 80,000 pounds for a truck. When you look at pavement design, it's based on flexure of the pavement. So you increase the load 10%, your deflection increases more than 10%. So your stress on the road greatly explodes. When they did that, that pretty much destroyed the history of how our performance went, because we had roads that were brand new that would rut. We had roads that were 10 years old and looked beautiful 2 years ago. All of a sudden they started rutting and going to hell, okay? So it was a crisis. Out of that came SuperPave, the Strategic Highway Research Program. Out of that birthed the new PG binder grade, which was monumental leaps ahead of what we had in the past. The old way we used to test asphalt binder was a pen test or viscosity, very archaic methods, but it worked good in those days because most of the asphalt back in the 40s, 50s, 60s was distillation towers, and fairly consistently. Anyway, long story short, these demands we put on pavement today exceeded the capability of natural organic asphalt. Asphalt, crude oil is an organic material, okay? The problem we have with organic materials is they oxidize. I was talking to a research chemist one day. I says, how do I explain to laymen what oxidation is? And his term was basically, well, you can't unfry an egg. When you fry an egg, that's basically oxidation. So I can take that egg and I can throw it in my blender, put in a couple drops of oil and blend it, and then I can do a pen test on it or a viscosity test on it. Man, it looks like that original egg, doesn't it? But is it still that original egg? Yeah, no, it's not. So that's what we're dealing with when pavements age. So this is a research chemist level type thing to rejuvenate these things. It's far and beyond the capability of any of us in this room to figure out exactly how that's going to work with all the variable products that we have out there, with the variable amounts of wrap that we have out there, with the variable amounts of chip seals on pavements. It's getting extremely difficult to do that. Hence, we're talking about balanced mix design. That really is the future of our industry. We've got rutting down pretty well. Rut tests work very well. Cracking is still floating out there. We don't have good ways that I can reliably get, what cracking number do I need in my knot on a 5 million ESO road to get it 20 years? We don't have those kind of engineering values. We don't know those things. We've got tests that we think are going to help us get to that way, but that really is where the future is and why they're investing a lot of time in balanced mix design, because no owner of a pavement can figure out everybody's additives. It's impossible. That's something the industry's going to have to do, and it's going to have to be driven by a test that will address cracking appropriately. We've got a lot of them out there. But I'm telling you, everybody, we're going to ideal CT now. Why do you suppose we're concentrating on that? Because it's easy, it's simple, it's cheap, okay? The future is not going to be easy, simple, and cheap. We're going to have to do real engineering on this if we're going to account for all these additives that come in there. We're going to have warm mixes, we're going to have all kinds of recycling things that we can do out there. But that can't be addressed through the historic way we've done business, which by that I mean is ingredient-based. We're going to give you an aggregate spec. We're going to give you a binder spec. and the agency is going to assume all the risk and move forward. Because you can't write specs to account for all of these additives they have nowadays. So I just offer that. And that should generate some questions.
We got a question down here. What's it?
Just real quick, for all the owner agencies in the room, where do you think the low-hanging fruit is for improving their pavements with additives, and what testing is involved? How would that be specified? Just what can they do to put this to work?
Yeah, I mean, I think the lowest hanging fruit is boosting RAP content where you can. I mean, I think we've shown how you can test for that and how you can do it. I mean, and that's why I brought this slide up. You know, the difference between a good recycling agent and a bad is how it ages. Like we've been talking about this, and so through these tests, you know, and through an aging protocol, you can kind of see whether or not you're improving what's there. So I think that's the low-hanging fruit. Within these tests and balance mix design, albeit them not perfect, to Mark's point, I think you can start to kind of track how your pavements are going to look by doing these tests like ideal CT, but then going through the 20-hour aging like you did on 14 and seeing what's there. And I think you'll have some very easy ways to discern what's something that you do want in your asphalt and what's something that you definitely do not want in your asphalt. I think that's there for you to kind of start understanding now and today.
Yeah, great response, Ryan. That's a great question. Take this with a grain of salt because I am a warm mix additive salesman. But with that being said, I feel like the low-hanging fruit here is using a warm mix additive that doubles as a compaction aid and a liquid adhesion aid. And the reason is what you're getting for that cost. A ton of asphalt is around here, maybe $90, Mark, 80. Is anybody? A ton of asphalt mix. Anybody? It's in the 70s. Oh, thank you, Mr. McCormick. So it's about 70s. So a typical dollar rate for a warm mix chemical that is going to give you a compaction aid, it's going to give you liquid adhesion, it's going to make it bond, is about $1 to $1.50. So in terms of percentages, we're talking about a lot of benefits for about 2% of that cost. And I feel like that's a real low-hanging fruit. But I feel like that's why we also get the monikers of snake oil salesmen, because I say, hey, you know, what do you want? Do you want to increase performance, or do you want to be good for the environment, or do you want to be good for the people, or do you want to increase adhesion, or do you want to, you know, just look for compaction? So, you know, it's hard to kind of pinpoint what additives do because they all do something separate. But in terms of low-hanging fruit, I think if you look at some of the other states that have really adopted warm mix chemistry, and warm mix chemistry being a double liquid anti-strip, it's a really easy addition to get improved performance for a mix.
Yeah, does anyone else out there want to speak up? I have a question on the low-hanging fruit, so to speak, what you're looking for out there? Because we can talk all day on what we think low-hanging fruit is, but as the owners out there, do you have an idea? Thoughts,
or
challenges, or challenges that you want to, hey, we want a 100-year pavement.
Steve, man, those knees can't handle it.
It's easy. It's getting low for that. It's easy. Little hamstring on there. Right.
The lowest hanging fruit I can find for an agency is spec the right oil. Get rid of the 28 in our country. It's not an oil for us. That's, your thermal cracking is there. It's not going to do it. Get us the right oil to work with, and you'll have much improved performance right off the bat.
I'm sorry, I caught just a little bit. Give a better oil, a better spec grade instead of a minus 28, like a minus 34. Is that what you're saying?
Yeah.
Yeah, that makes a lot of sense. And I think that speaks to the rejuvenator side of too. You know, the harder oil you get on that side, you're not going to have the cracking abilities. It looks good when you lay it down, but testing-wise, it's not going to test.
Any of the asphalt suppliers want to give that little number out, what it kind of is, the difference between a 5828 and like a 5834? I mean, just a ballpark figure?
Yeah, I mean,
No, I mean, I'm talking about price-wise here.
Yeah, we probably don't want to talk price in open area with competitors all around, so probably want to avoid
Well,
that.
I'm just saying in general.
But I mean,
well, I'm saying, is it $20? Is it 50? You know what I'm
it
saying?
depends regionally. I mean, to get to that though, there's more than one way to do that. The whole idea behind balanced mix design is you shouldn't have to worry about what grade of oil the contractor's using because of additives like this. Here's an example in Minnesota. They did an additive test, NRA did, near Emily, Minnesota. And they basically just wanted to add, I think it was 40% wrap. Yeah, it's right there, sorry. They wanted to add 40% wrap and just maintain their grade, right? So by using that, and this is, Invigorate's not the only one that did that. I believe they had an EvoFlex from Ingevity there. They had the Innova from Cargill. You had everybody there. It was like 8 different sections. And almost every single one of those products, except one, I think, was able to maintain that grade there. They can't do that unless they're already softening that. So you say you're not getting the right oil. Well, if you're not getting the right oil spec, you could also add 2 to 4% to this, depending, and you can check it with Aaron Swan or with any mix design lab, and you can get those thermal cracking problems addressed just with that additive. Because guess what? You're kind of blessed here in North Dakota with having refiners that can make soft oil. There's a lot of places in this country where they don't even make 6422. They make something that's black that some people blend a lot of things together that resembles asphalt. It's really. Ask Auburn. They deal with all these types of products all the time. Ask NCAT. So there's more than one way to skin the cat, and the refiner is never going to be incentivized, especially in a gas oil short area, to make that softer binder anyway. So that behooves you to understand these additives, understand what works and what doesn't, and we've kind of shown you the metrics, so you can get the right oil, regardless of what comes off the tap of the refinery.
I have a couple questions for the panel. So first question, it's Amy Bisey, materials engineer. So do you think the benefit of additives is we're maybe not trying to completely change our hot mix, but maybe to take a good hot mix or asphalt and tweak it, make it better? Or do you see it as something that's completely going to change the way we do mixes in the future? My second question is, flip side of it, what are some of the impairments? What are some of the barriers to implementing these things that you've seen?
Well, all the barriers, that's easy. That's the DOTs, right? No, just kidding. The barriers are both the owners and the contractor because they're both new to this. So let me answer that one first. And education, I know it sounds, education is the key for it, but it really is. It is really kind of where you have to kind of meld the minds and work together. You guys did that in North Dakota 14, right? Like, I can hear Corey saying it. Wait, you want the pavement to maybe fail? Like, yes, because we want to learn what that looks like. And so that's kind of the challenge is having that partnership of trust to do that. I think that's the biggest thing. And with these additives, it's no different. You're trying something new. To answer your first question, that's a hard one. I do think, like I said before, what you're doing is not revolutionary. I think what you're doing in addressing your asphalt is merely enhancing what your asphalt is there to do. But by doing that little thing, and again, I'm harping on BMD, but I think that is a pretty revolutionary concept to say, yeah, maybe know what your volumetrics are, but don't care about those, and then just care about these performance tests. That's massive. That's a whole new way of thinking about paving. So I hate to vacillate between the two answers, but I think it's both.
As far as implementing into our mixes, we've done the Evotherm to help with our compaction. So we've made our mix a little easier to compact to get that density out in the field, which is what we want for our asphalt mixes. And this is going elsewhere too as well. But other technologies have helped us with that compaction with our IR bars, thermal cameras, density machines of that nature. So now that additive kind of goes by the wayside when we're able to control that through other means. So the continuing innovation that these guys are doing with their admixtures or these additives and stuff and incorporating them into the mixes, I think is good and ever changing. So yes, we are making that mix better, and we're getting back to the point where Mike originally said asphalt's the prime ingredient, and that's what we're worried about, and that's what we're doing. And we went with Evotherm, I guess, dancing around here, but adding Evotherm to help with the compaction aid is how we kind of first started using Evotherm in our area, and now we're getting to a point where we don't need to have it so much anymore for compaction aid with our other technologies. So, but another aspect of that then is our TSR, our stripping, using that additive in there for the stripping and making our mix better. No doubt it's going to make it a lot better. We use lime, we use Evotherm, Nova. There's a bunch of products out there for that stripping. So I think adding them into our mix to make them better, yes, they're at small dosages. We're not changing the world, so to speak, on a lot of these mixes that we're doing. We've gone to the weeds and to the heavy high wraps and rejuvenating and different aspects that we can look, and those are different beasts. So, but I don't know if this kind of helps your answers anything, but our normal mixes, yes, we're trying to make them a little bit better, and through that technology, we've learned that we can get to that point without even using them. So, I mean, if that helps with that.
Well, we're getting to the end, so if you got any really closing remarks here.
No, I'll just add on that. We're additives, as much as I'd love to say we're changing the world, we're not reinventing the wheel. I think it's just giving you guys a little bit more tools in your toolbox to do a hard job. I think the obstacles for me surrounding warm mix, Steve just hit it on the head. If you don't need a compaction aid, I feel like the key in running a warm mix additive is your liquid anti-strip and your adhesion. The other side of the benefit is by using a true compaction aid warm mix chemical, if you are lowering temperatures, you're going to get a lot better binder properties. You're seeing that through balanced mix design. That's 100%. So, I think the obstacles that come with that are people on the production side. They're going to be worried that the drag slat might not take it. I think you need to, give them the tools to work through these things. You need to give them the education. Maybe we need to put a bigger motor on top of that drag slat so they're not worried about shoveling it off. If they're worried about the baghouse temperature, maybe we need to address the veiling in the drum to either let a little bit of heat to that baghouse, so we need to get the temp up so we're not worried about being under 212, or we need to just change some things around. But there's tools that we can do to help, but we need to give our people the resources to do these things. I think it's just disingenuous to give them the outcome that we want without the tools to do it. That's my take.
Is there any other questions, or otherwise that's going to conclude the session for this afternoon here? Tyler, you got one?
I'll just give one quick one. So we've found kind of an area of our state where we found kind of a significant aggregate stripping issue. It's the southwest, basically quarter. We've tried Evotherm on 2 jobs as a liquid anti-strip. I would say we had a good result on one and maybe a more moderate result on the other. Just with what I guess the panel is seeing, any ideas for that of products that have worked, your experience maybe with lime versus the liquid anti-strips, just if you can expand on that a little bit.
I'm very biased, so I'll pass this along.
So I know what Tyler's talking about. We did one of the projects over there, and so lime is still a really good additive for our stripping for our materials in our neighborhood. It still performs really well compared to some of the other ones, the Evotherms, the Novas, some of the other additives. As far as which one's better, I mean, it's what number you're looking for in the end. South Dakota, we use lime is the #1 anti-strip agent. We don't use anything else in South Dakota. North Dakota allows multiple options there. You just got to prove that we can get what we're looking for there. When we're talking to the southwest part of the state there, what Tyler mentioned there, we have a lot of those type aggregates in South Dakota as well and have to deal with them. And lime still seems to maybe be up a little bit higher than from my experience and my designs and what we've done. So I don't know if that help answers.
I think how you're testing them too ahead of time is important. Again, I don't mean to dog on the TSR, but I do mean to dog on the TSR. I hate that test. I think it can be very misleading. I think you can have very high TSRs and still have stripping problems, and I've seen it a lot. So I would look to your Hamburg and your SIP. It's not perfect either. And maybe running some of those on your mix designs to see if you're going to have those potential problems. And I would run them with both liquid anti-strip, and I would run them with the lime and see what you find there, because I think we rely too much on TSR to tell us what we're seeing, and then we're surprised when it doesn't pan out, and we shouldn't be at this point. Bluntly, sorry.
Tyler, was that being dosed at the terminal or at the plant? One of each.
One of each, yeah.
Interesting. Which one worked out better? At terminal blended?
Terminal.
Okay.
Not to throw the contractor in the bus, but
Yeah, you can make your own conclusions.
So what can happen is with a terminal, generally you're using better flow meters, and so you might be getting a more accurate rendition of how much is going in there. And sometimes with these skid mounted things, they can have issues. There's some best practices that Ingevity can help you with. I'll say it for him so he doesn't have to on running those. That would be what I would point to if you had way better results at the terminal, potentially. I'm not saying you need to do terminal add only, because I can tell you the terminals don't want to do that in general. You're going to have much better luck if you can have a reliable system in the field at the plant, but that might be the variability that you see.
Also, some of this too, I think, maybe we want to use a combination or try a combination of things. As everybody's pushing that one thing, maybe we want to try two things. I mean, I don't know. Try everything that you possibly can. These are just, we got these tools, but I mean, we got to try something. We got to use it. And I know that southwest part of that North Dakota the aggregates are really absorptive. They're terrible.
And it might be good for stripping with lime, but you might take a backdoor on the cracking test with that. So I think it's how you balance all your inputs and what your hopeful outcome is.
Do we have any other questions other than that? I think I think it's a social hour if you're into that kind of stuff in life. Lucas, you raise your
Lucas,
hand. Do
you
you
got
want
it.
to speak? Oh, come on, Lucas. Well, thanks everybody.